All right, the session's being recorded now. Hello, everyone. This is Jaya Kishore Esanakula. That's my full name. I go by Kishore. Good to see you all. If you're joining new today, what I'd like to do is I'd like to go over some of the information that I shared with you yesterday quickly. We're trying to cover as much as we can today. There's a lot of content, so please stay with me. And if your friends are coming online, or if you see your friends are missing, please communicate with them, text them, however you can. Please bring them on. So we're going to be starting new content today within 5 minutes, but the first 5 minutes we're going to be going over what we covered yesterday. You will have plenty of options to ask questions. I'll try to make sure that you get more Q&A time today than yesterday. Without any further ado, let me go ahead and share my screen. All right. Let me go back to the beginning. All right, okay. We're here at the beginning again. For those of you, we talked briefly about the philosophical context to give you an idea on what I believe in, change, life, and learn. You may have seen this before, so I'm not going to spend any more time. Aloha at the bottom. When you get these slides, please read about what it is, what it means. Give a brief overview of my background, where I come from. And I am one of you, graduated in 2002. So please read through that and you get an idea on what my interests are and such. Hobbies, definitely read through them. Have them. You should have some hobbies in your life. We briefly covered about current state of affairs with COVID-19. The second bullet point, I shared a few resources yesterday, URLs in the group, in the WhatsApp group, the JAMA journal. Most of the content is free for access. Please read through those and stay updated. And I highly recommend that as you get close to your projects, or even right now, pick a field of interest. I would personally, selfishly think it's healthcare. And please see if there is anything on the JAMA journals that you could contribute to, or you can pick from and make a project out of it. Work with your professors. One key thing that I want to drive on this slide is that at the bottom, all the way at the end, healthcare data is actually doubling every 72 days. That is an astounding statistic, but it's true. The data is becoming twice as it was every 72 hours. This is because of, this is pre-COVID, by the way. It could be a lot, the days could be 50 days now. This is pre-COVID statistics. I see someone raising a hand. Let me pause here real quick. Did somebody raise a hand? Somebody have something to say? Okay, probably a false message there. Let's continue. We will have pauses and breaks for questions. Okay, let's continue then. So I'll get back to presentation here. And I'd like to draw your attention to some of the things that I highlighted on this slide. When you get this slide, you'll be able to read through those and you'll see what it means and what it is. But at this point in time, let's quickly glance through this. Anonymized, centralized. So patient data is going to be spread across all over the hospitals and their radiology departments, their labs, their inpatient, ambulatory clinics, so on and so forth. There is a need to share anonymized, meaning patient data with no identifying information with other hospitals for research purposes. If the city of New York, state of New York, for example, is not sharing their patient data, anonymized patient data with the rest of the world, rest of US, and vice versa with Italy, Spain, and China, would be in a much worse situation than we are right now. Because of the fact that they are sharing the anonymized or de-identified patient information with the rest of the world, we are able to somewhat, relatively speaking, fast track the research that's going on into identifying and understanding what the nature of the COVID-19 is, and mutants are how it's mutating itself. So it's very key to share anonymized information. Let's see, wearables. So when it comes to medical devices, wearables, especially the ones that you're wearing, the ones that measure your number of steps, your calories burnt, or if you have a much more advanced wearable device, the wearable device might be able to measure your heart rate. It might even be able to sense the onset of cardiac arrest here pretty soon. There are devices out there right now, but they're going through FDA approval, and they'll become available for public use. So the point is that the amount of IoT data, Internet of Things, wearables data that's being generated right now today, right, far exceeds the amount of data that we can actually understand. So it takes processing power, it takes analytical power, it takes um, a lot of analysis on a lot of different places to actually understand what that means. In the context of a hospital, think of devices that are connected to the patient in an ICU setting. So those devices are sending IoT data back to the electronic health record system. Some of the examples of electronic health record systems are Epic and Meditech. And that data is coming at a frequency of every 5 seconds. Some of them actually capture every 2 seconds from the patient, the oxygen saturation levels, carbon dioxide saturation levels in the air that's being inhaled by the patient and exhaled by the patient. The last bullet point here speaks about interoperability between hospitals, interoperability between different countries who are intending to share patient data for the purposes of finding a cure for COVID, for example, or finding a symptomatic cure for the time being and eventually vaccination. HL7 is a encoded messaging over TCP/IP, very old school EDI. It's basically EDI side of healthcare. So if you heard about electronic data interoperability or interchange, then you're aware that HL7 is a healthcare standard for data exchange, and there is standards for transportation logistics, claims, banking, you name it, there are different standards. This is just encoded messaging over TCP/IP, nothing fancy. FHIR is your RESTful services. If you're familiar with web services, FHIR is nothing but RESTful services for healthcare, JSON messages, resources, with put, post, get messages being exchanged between systems. Clinical data architecture is a standard that was published within the United States by a consortium or a group of people who cared about the value of having a common interface so that the electronic health record systems can exchange information freely between themselves. Let's see. So I've broken up the sessions into 3 main pieces here. Well, we have 2 sessions, but there are 3 modules within there. Healthcare capabilities, I'm going to go through that, and then we have clinical decision support systems. We started talking about that a little bit, and we're going to get into AI/ML. The question mark at the end of ML is intended, not a mistake. Machine learning is a part of artificial intelligence. They're not peers, they're not synonyms. Artificial intelligence includes natural language processing, machine learning, image recognition, and a few other fields that are beyond the scope of this subject for now. Now, when it comes to healthcare capabilities or hospital capabilities, we're looking at corporate hospital systems. You could have, I'm going to stick the second one for a second. You can have ambulatory clinics, primary care clinics. Ambulatory clinics and primary care clinics are the ones that we're more familiar with. And then emergency rooms and trauma centers. Emergency rooms are something that you don't want to know. This is something that's, personally, emotionally, it's not the best of the things to be going to an emergency room, but they are important. They are part of the healthcare capabilities. Trauma centers are basically your emergency rooms, but they're specially equipped to handle psychological aspects of an emergency. For example, if somebody's involved in an accident, or somebody lost a loved one, or somebody's going through COVID. COVID is a good example where there's a lot of stress and strain on the human being when they're going through COVID. So they handle the psychosomatic, psychological aspects of an emergency room. Trauma centers also handle children. Children go through trauma. They could be involved in an accident, or gunshot wounds are pretty common in some of the states. I'm sorry, some of the cities in US, not just in US, some other parts of the world as well. All right, so I went through different sizes of hospitals here. I don't want to go through every single detail in here. Please do read through, but broadly understand that the hospitals can be classified into three different types. One is a small healthcare organization, which will have its own ambulatory clinics, inpatient, emergency, and trauma might be optional. Medium, it'll have all the things that a small hospital had. In addition to that, it'll have specialized departments for labor and delivery, cancer treatments, and separate trauma centers for children and adult. However, they'll have a centralized billing and centralized pharmacy. And they may also have clinical research with interventional clinical trials. So as they try out different medications on patients, they might learn nuances that work for a given demographic of patients, and they'll start sharing that information with the rest of the hospital system, so they could get benefited from the newfound information. For example, well, I don't want to take any medication names because it's controversial right now, but if there's a treatment protocol that worked for a male 50 to 70 years of age with diabetics and high blood pressure, the doctor might share that piece of information and say, this medication seemed to work the best for these patients, and the rest of the hospital, rest of the patients, and the providers, physicians, residents would benefit from that information. That's the last bullet point. Interventional clinical trials, that's what it means. Usually interventional clinical trials last 6 months to a year, but because of COVID reasons, it's pretty much a weekly basis right now. They're exchanging information on a week-to-week basis on what is working, what's not working. A large healthcare organization is everything that the medium will have. In addition to that, it'll have joint ventures where it would start their own. They would have their own clinics. They might have centralized management offices, and they're so big they can actually negotiate their own rates from the insurance companies, from the payers, to be given more money or discounted money, depending upon how you look at it. And meaningful use is specific to US, so you can search for it. I don't want to spend time on it. And population health management. So there are entities out there who care for the quality of life of the human being overall. For example, the governments, right? They care about how healthy people are. So population health management tools help hospitals go beyond their scope and actually look at the patient at a broader with a broader stroke. And they can look at the patient's health records throughout their life. So there are specific analytical tools that would help them do exactly that. And population health management is also a key component of compliance reporting back to the government, so that the governing bodies get to know what kind of care, the quality of care, patients, how safe are the patients being treated at a given healthcare organization. Before jumping into the clinical decision support system, I want to take a quick pause and ask that, if you have any questions, please let me know. I'm going to pause the sharing for a second. All right, Mr. Hari, you're the host now. Students, if you have any questions, now is a good time to pause for a quick couple of minutes.
Sure. Students, if anyone having any queries, you can ask the resource person now. Please raise your hands if you're having any doubts or some other. Is everything okay? Then we'll be continuing. Sir Kishore said, so no one has raised
Okay.
their hands so that
Okay. Well, let's continue.
then we can
Please,
continue. Sir.
yeah. If you don't mind making me a host again, I'll start sharing.
Sure, sir. It's done, sir.
Okay, thank you. All right. Now, please lower your volumes on your headphones. There's a video that I want to share about clinical decision support systems, and we're probably going to skim through the rest of the slides on this topic fairly quickly because we covered this yesterday. And the video is actually very, very elaborate and very nicely put together. No need to write down any acronyms or anything like that because they don't mean a lot for you. All right, let's play the video. Something is not working right with the video. Bear with me here. Well, we can cover the same content in the slides, so I'll go through the slides for now. And I'll share the video link in the WhatsApp message in the group. Please do go through the video at your own time. So it basically covers what a clinical decision support system means and how it applies to the patient, to the provider, to the hospital. In a nutshell, imagine this. A doctor is sitting in front of a patient and the patient is going away explaining their symptoms. They have cold, cough, itchy eyes, throat, whatever the case might be. And the doctors, basically based on their education in the medical school and based on their practice and experience, they're going through a flowchart of things in their head to figure out what could possibly be going on with the patient. So over a period of time, as that decision making has evolved to the point where the doctors have documented those decisions, those flowcharts, and standardized those decisions and flowcharts, they'll become what is called clinical pathways. The different pathways, different ways, or different avenues of diagnosing a patient. Now, these decision support systems have been put together into computer-based applications or systems using rules-based expert systems, using basically if-then-else while loops. And if you're familiar with RET algorithms, when it comes to rules engines, that's exactly what the rules-based expert systems are based upon. The second classification of decision support systems basically leverages artificial intelligence. That's the bottom part here, no knowledge-based single system CDSS. Don't remember any of these acronyms, but the gist that you should get to is that we are evolving as humans. Initially, we had expert doctors who everybody would say, oh, for this surgery, for this particular syndrome or symptom, you should go to that doctor. He's amazing. We're beyond that. Because those standard practices are now being documented at hospitals like Johns Hopkins and Mayo Clinic, and they are publishing their clinical pathways for free to be used by the rest of the world. Why do we need a clinical decision support system? Basically increases the quality of care, and you can read through the bullet points here. I want to get into every single one of them right now, but when you watch the video, you will get the gist of these bullet points in a video fashion. Basically elaborating the two differences. Now, when it comes to RET algorithms, there are several industry standard implementations out there. There's organizations that charge big licenses. Microsoft has one, MuleSoft, Azure, AWS, I didn't include it here. AWS has their own implementation. TIBCO, Pega, you name the big box enterprise application integration suites, they all have an implementation of a RET algorithm or RET algorithm-based rules engines inside them. And as you can see at the bottom, the second type of decision support systems are based on EI and ML. We'll get to them in a few minutes. Clinical pathways, there's a resource link down here. Please go to that link when I share these slides to learn more. There's a lot of information out there. clinical protocols. Once the doctor goes through the if then else flowcharts in their head and figures out what exactly is wrong with the patient, they'll have to put together a treatment plan for the patient. And depending upon the symptoms, age, any other comorbidities. Comorbidities is a glorified term for maybe other conditions that the patient may have had historically, like for example, diabetes and high blood pressure, maybe history of a particular kind of illness in the family or family history. Once the doctor figures out what the treatment plan is, they'll execute the treatment plan, and over a period of years, these treatment plans have become so good, so well written, so well organized that they started calling them treatment protocols. And again, majority of the academic medical centers are hospitals that are associated with universities and medical colleges, and they are publishing clinical protocols. They have been publishing clinical protocols for specific sickness, illness, or symptoms for a period of time now. Again, I'm going to take Johns Hopkins and Mayo Clinic as two of the examples of that they've been publishing. Cardinal Health is another one. They've been publishing clinical protocols for wider use, so that the eventual utopian vision is to have the same level of care that's available for someone going to Johns Hopkins Hospital be available to someone in a remote area in Africa somewhere. All right, we were at questions not too far ago. Next slide, I'm going to go through it quickly. It was supposed to give you some information about what my hobbies are rather. I like racket sports, and these are a set of my rackets that I use. The first one is these are all pretty old, by the way. The first two are more than 10 years old. I play racquetball. First one is a racquetball racket. Second one's my tennis racket, about 12, 13 years old. Some of you, if you're familiar with tennis and you do play tennis, then you recognize that this is a very old stick-like racket used by Roger Federer about 2002, 2003 timeframe. People don't use these rackets anymore, but I got used to it. I'm stuck with it. December last year, I got this new badminton racket. I rather like it. I used to use Yonex before. Right now, I'm trying this leaning Winstrom 770. Not bad. When I do show up in campus in college at some point, I'll try to bring some of these or all of these. Maybe we could try out in our college. By the way, the facility, our college, has evolved quite a bit from the days of when I went through college. You are so privileged. The library, the new innovation center, the athletic, all the athletic facilities. You are blessed to have all of them. I am comparing them to some of the athletic facilities that I have here as I was going through my master's. They're better than the facilities right now that you have in campus are better than the facilities that I have here from my personal use. So you're blessed, you're privileged. Take advantage of them, use them, be thankful. Looks like my videos in my slides are not playing nice with me, but I wanted to show you what racquetball means in a 2 to 3 minute, but we're kind of short on time today. So we're going to skim over that, and you'll get the links in the WhatsApp group, and you can use that. All right, quick fun fact. I wanted to have you participate, but looks like the Zoom, the way that it's set up, it's not going to let me. So I'm just going to quickly go through. These are all the rackets that Roger Federer's ever used. And all the way at the bottom right here, the oldest one, actually, this is the oldest one. And this is my racket right here, as you can see. He's evolved quite a bit. So some of the rackets that you see on the top half of the screen are probably half as heavy as the bottom half. My racket is a hammer, so it's a hammer, literally. Thor's hammer. It's pretty heavy. Well, why do we need artificial intelligence in healthcare? As we try to zoom into the clinical decision support systems, I want to zoom out of the context just for a few minutes. What's the fundamental reason, right? The cost of healthcare is raising a lot, especially in US and even in India. And there are aspects of healthcare that in India that I really loved and liked, but they're changing to the worse, meaning they're becoming close to what Western world calls healthcare, which is a bad sign. And then the next point is that the clinicians, the doctors, are overworked because there are not many of them in general in the world, because of the fact that people are getting more and more sick, and they're leaning on hospital or clinical care more than leveraging food as a care or a way to make sure that they live healthy in the first place. The third bullet point, operational efficiencies. These are things like, for example, right now, if a patient comes to a hospital with COVID symptoms, at the beginning, I mean, as soon as they're admitted, the hospital administrator, the chairman or the CEO or the head of the hospital is thinking, a president could be, they're thinking, oh my God, okay, we have a new patient. What is the age group? How long is this patient stay in a particular isolation room? Because we have plenty of patients who could come through, and we need to make sure that there's enough capacity to care for the sickest of the sick as far as the patients go. If the patient is you know, a fairly young, let's say 20-year-old male who used to be an athlete, and he or she doesn't have any history of respiratory illnesses, then the chances are that they're going to be discharged from the hospital, meaning they're going to be discharged to an isolation fairly quickly. They don't have to be in an ICU unit. They can be discharged to an isolation unit quickly. However, if the patient is a 60-year-old with the history of respiratory, then the chances of them being discharged quickly are low. They may have to be put on a ventilator. What is called the length of stay. That's the model that I'm trying to allude to. So the hospital admin would like to know what is the predicted length of stay for a patient, depending upon um, certain features of a patient. So to improve the hospital operation efficiencies, things like length of stay for a patient can be predicted using AI and ML. Ever-changing regulations, the next bullet point. So let's skim over the ever-changing regulations for now, because they're so subjective and they don't mean a whole lot for us in India compared to US. So let's just ignore them for now. And evolving clinical pathways and protocols. This is key. This is a key thing right now. Typically, clinical trials, when patients are given new medications or vaccinations or immunotherapy or even symptomatic treatment, they evolve over a period of time. Right now, unfortunately, we don't have the time with COVID. We're evolving weekly. You see JAMA articles being published. I shared the URLs with you yesterday. Please do read them. They are the sounding board of the provider or healthcare physician community right now. The articles are coming out almost every day, so please read them. So clinical pathways and protocols are evolving for COVID, and they're changing very fast. Well, we're getting into somewhat the analytical side of the artificial intelligence and machine learning side of the deal here. When it comes to analytics in general, analytics can be understood as a pyramid of three different things. All the way at the bottom is your descriptive analytics. Typically, they answer questions like, what just happened? They're usually retrospective. So from an OLTP database, if you understand what it means, is a online transactional database that stores all the things that have happened, and then the day after they'll dump the data into a reporting database where they could run analytics on that, and they could answer questions like what just happened yesterday in sales or in a hospital and such. That's called what is called a descriptive analytics, all the way at the bottom. The next up top is what's likely going to happen. If you have the ability to predict, then what's likely going to happen. Forecast, weather forecast by IBM Watson. It's just a small aspect of IBM Watson. And then you could have, for example, the length of stay I was referring to at a hospital. It's also a machine learning model. Usually length of stay is calculated using regression algorithms. Now, I want to take a pause there. I used an algorithm. I said linear regression or regression algorithm. One of since you're in an academic setting, what I would highly recommend that you do is that understand if you're keen or if you're interested in healthcare, understand the context of healthcare, understand the different terminology, understand how things work, try to get into the head of a doctor or nurse. Don't try to get focused too much on a particular algorithm, because they change very often. There's new versions being published. And also at the same time, don't get married to the algorithms or the platforms or the programming languages. Over a period of last 3 years, let me give you my own example. Well, 4 years. I've developed models in R, Python, SAS, TIBCO Streambase, PMML, and a few other things that didn't make fruit or bear fruit or make it into production. But things are changing constantly. So if you can write with a pen on a paper f of x, you can execute a model. So don't get bogged down with languages being used, platforms being used, or algorithms being used for a given um, machine learning model and artificial intelligence model, because they change. And be adaptive, be have the zeal in you to learn what is the next one, what is that. So keep that light in you lit all the time. And I was a big fan of C++ when I started developing, but well, I could still do C++ if I wanted to. But the thing is, things are constantly changing, and you pick the tool that's right for the need or right for the problem. All the way up top, this is prescriptive. So once you know what's going to happen, or once you predict what's going to happen, then you can actually prescribe what should happen to negate the effects of what might happen. And the next slide actually lays out a nice picture. Let me get to the, well, okay. We're a little down the ways for that. So once you predict what's going to happen, then you can take corrective actions and pick the right corrective action to make sure that what you want to happen will happen. Let me give you an example. Let's say that you have an autonomous car, and the autonomous car is driving, and the autonomous car figures out that based on the momentum, speed, the direction it's heading, it's going to predict that, okay, you are going to go off the road in about 50 feet. Based on the prediction, it's going to figure out, okay, you're going this fast. Do I need to put brakes on? Is the steering input just enough? Are we going to go off-road? Is this going to cause the electronic stability system be overwhelmed and lose control of the car? So based on all those parameters and yes/no answers, it will figure out the best course of action and prescribe a certain amount of braking, certain amount of deceleration meaning regenerative braking, and then certain amount of vehicle stability control inputs to different wheels of the car, maybe accelerate certain wheels, maybe slow down certain wheels, the four wheels of the car. And eventually, all it wants to make sure is that prescribe a way to negotiate that turn safely. Now, by the way, autonomous cars are a finicky, funny thing. I own one, not fully autonomous, but I'm going to tell you this. If I leave my car to drive from here to my office, it'll do that just fine. But if I set the speed limit any higher than what I can handle, trust me, it'll get me to my office. I might throw up once I get there because it'll drive as fast as it can. And that's not humanly possible. So just a funny fact there. Not so funny if you throw up, unfortunately, but yeah, that could happen. Now, when you think about analytical maturity models of an organization, by the way, these terms that I use, organization, you have to be thinking about them from a very early on in your career. If you can write a hello world, if you can write a if then else while loop on a given language on a program, there's a lot of things that you need to think about beyond writing little code snippet or thousands of lines of code that you should be aware of. There's aspects of programming that we will touch on in a future session there's an up-and-coming session on enterprise architecture where we'll get into non-functional requirements. But at this point, for this session, realize that there's a lot that happens within an organization than just purely writing a piece of code and delivering it. What's important is that from left to right, imagine on the left-hand side, an organization is trying to understand what's going on in their hospital. And then they start doing their descriptive analytics. Descriptive analytics is basically running reports. They could be using any set of reports. They could be canned. They could be on-the-fly report that they create to measure and diagnose what just happened yesterday at the hospital. As you go to the right side, so the immediate need, you must have these dashboards. That's immediate need. This is, when I say immediate, meaning this is emergency. If an organization doesn't have descriptive analytics, they're doomed to go down the abyss. They're not going to survive. As you go to the right, value add, an organization that has some sort of a predictive analytics going on for them in favor of them will be a value add to the general healthcare in general. If a hospital or if a pharma company or if a pharmacy, if they don't have any sort of predictive analytics that they're leveraging right now, they are doomed. They are not going to survive. They need to have predictive analytics in place. As you go to the right, the organizations that have prescriptive analytics will have the competitive advantage over the others. Um, Let me spend a little more time here. Let's see. Okay, I think there is another slide down the road that's going to cover this in detail. This is very similar to the slide that we just saw. However, this paints a little different picture. There are acronyms here. You may understand RDBMS is database, right? Data warehouse. ESV Enterprise Service Bus basically enables you to do complex event processing. Which is CEP right here. ESV can be used to do pure just integration, or it can be used in an advanced implementation, implement rules-based expert systems and leverage complex event processing to implement decision supports. All the way at the top is PMML. It's a new acronym probably for you, majority of you. It's we're going to talk about it in more detail in a couple of minutes, but what it is that once you build a model in a development environment, you have to deploy it in production. One of the ways to do that is there's a common standard to make models more portable, and this standard has been defined by the open data mining group, and I think it's 4.2 or 4.3 anyways. They're constantly evolving in the way that the models can be made portable. So think about this. If there is a hospital in Johns Hopkins, for example, and they've developed a model and they want to make that model available to everybody in the world, how do they do that? Well, they could just export the model in the form of an XML. PMML is nothing but an XML document if you open it and start reading it. And the model can be given to any other hospital that is able to provide the right input to the model and use the right platform to execute the model. So PMML makes models portable. The key thing that you should drive away from here is that the models are portable and models can be implemented in different platforms. And PMML is one of the ways of making the models portable. So as we were looking at the different kind of analytics, there are different kinds of machine learning algorithms as well. Up top is supervised learning. And in here, you actually reassure, you actually tell the machine that what it predicted is right or wrong. So when it comes to phases of machine learning model development, there are three main phases. One is test, and I'm sorry, the first one is train, the second is test, and the third is productionizing or implementing. In the test, train and test phases, you can actually tune or tweak your machine learning model to increase the accuracy and support of a particular model. That is usually called supervised learning, where you're actually sitting and looking at the model and going, okay, what you predicted is right, what you predicted is wrong. So increasing the accuracy of the model. The second type of machine learning algorithms is basically unsupervised learning. And there is some examples in here. Don't try to learn every single one of them. This is just an example at a point in time, and things are evolving. Do remember that. The classification unsupervised learning would stay there for a while, but the algorithms underneath that, they're constantly evolving and their implementations are evolving. So for example, Python might have a different implementation. R might have a different implementation, SAS might have, and there's plenty of other platforms that might have their own implementation. This is unsupervised learning is typically used in surveillance to predict, for example, anomalies. Let me give an example. If there's a red zone, popular COVID red zone in a particular geographical location, and let's assume that every single person in that red zone is wearing wearables and they have a watch and it's emitting geolocation information back to a mother station or the mothership. depending upon their locations and the way that they're moving around, we can, the surveillance system or surveillance algorithm can actually predict, not predict, but can actually recognize anomalies. If a particular person has a certain set of activities or movements that happens every day, then it can see that, okay, this person moves from here to here to here to here every day. And if that movement isn't happening for a bit of time, then it can raise an alarm and say, okay, either the person took off the wearable and put it on the desk somehow, or something's wrong with the person. He or she is not moving. So it can actually be used for surveillance. The third type is probably the bottom, all the way at the bottom here, is probably the most complex one, reinforcement learning. So I would leave it to your discretion for now. And I think I'm looking at the watch now. We don't have much time. So please, um, well, try to learn the Markov decision process first, and that would probably help you understand what reinforced learning means. But for the majority of our life in general, you'll be spending majority of your time in supervised learning. The up top black car is a Tesla. The biggest plus that a Tesla car has is that there have been in introduction since 2012. Every single Tesla car that's going around right now is a piece of computer that's capturing road situations and training and implementing models. Remember the predictive markup model language, the portability, the PML, the XML. They are sending data to their uh, central data center, where the data is being processed and used as training data to train models. And the model, in the form of an XML, is exported and sent to the rest of the cars, so that every single update a Tesla gets, it's becoming better at autonomous driving. It's becoming better at recognizing a cat versus dog. It's becoming better at driving in snow, driving in rain. So you're probably going to spend some time in your careers. I'm hopeful that you get to see some of the supervised learning and some of the benefits of supervised learning. Bring in full circle back to healthcare. There's a lot of benefits of using supervised learning in healthcare as well. One of my, by the way, one of my favorite algorithms, actually, it's listed as random forest, but an implementation of random forest is what is called a gradient boost. Do spend some time on gradient boost if you get some time to play around on your laptops. It's an x86 based algorithm. You don't need a GPU for that, and there's a lot of test data that's available out there, or train data that's available out there. I'll put resources into the WhatsApp group. I'm taking notes of all the things I'm promising I'll send. So there's videos and there's resources I'll be sharing on the WhatsApp group. Please use them to your advantage. All right, so let's go through the content. I don't think we have much time left. So let's go through the content, and we'll get back to the questions at the end. We're getting close to the time here. Quickly, motorcycles. I'm into motorcycles. I like riding. On the left is my current motorcycle. On the right is what I want to get. So on the left is a Honda CTX 700, and that's what I have right now. And the next one is a VFR 1200X. The right side, it's considered an adventure motorcycle. So this is, the right side one is in the same class as a, for example, Royal Enfield Himalayan. Bigger engine, probably bigger bike for, going across. If somebody's traveling around the world, they probably want to be either on a Himalayan or something similar. So the VFR 1200X is like a Himalayan, a little bigger than Himalayan. Again, a video there. I cannot get to it. We looked at the pyramid. I want to make sure that you glance at it one more time, right? At the bottom, you have descriptive analytics, you have predictive analytics, and there is prescriptive analytics. Now, when you jump into artificial intelligence-based capabilities, once you start implementing these using whatever choice of your algorithm, depending on the problem that you're solving, at this point in time, we have these tools implemented as, I shouldn't say tools, these capabilities implemented as assistants to human beings, or the manager of a human being, or even peer to another person. Or they're currently implemented as chatbots to answer certain questions. And then they're literally used as tools in certain scenarios. the assistant predicting onset of a cardiac arrest at a hospital and sending out a page message is an assistant, the use case of an assistant. Manager is once a doctor goes through clinical pathways and identifies a certain prognosis to a diagnosis to a patient, um, then the manager of that particular clinic or hospital can actually take the diagnosis and send it automatically behind the scenes to another set of doctors and get a second opinion automatically for the patient. This could happen behind the scenes, and actually this happens today. This is something that happens at a bigger hospitals at University of Chicago, for example, where I was working as a clinical application architect. We implemented a tool where the doctor's diagnosis, in certain cases, the doctor can ask for a second opinion. When they choose second opinion, it actually goes out to a select set of doctors randomly chosen based on the patient's symptoms. And feedback is collected. The doctors could be spread across the world. And the feedback is collected and sent back to the doctor who asked for a second opinion within seconds or within minutes, depending upon what kind of symptom it is. And the particular manager is using machine learning algorithms to compare different patients that the other doctors may have seen in the past, and looking at the clinical pathways that the doctor's taken, and they pick the best path and they compare it against the doctor who requested a second opinion, and send their feedback or conclusion back to the doctor. Say, what is the confidence level of his diagnosis from, let's say, for example, for a doctor in Brazil, what's his confidence level on his diagnosis, right? Maybe another doctor in India somewhere. So that's the gist of it. Peer is similar to assistant, except that the peer can actually autonomously take decisions. So it not only sends pager messages, but it'll send more information about the patient. It might even take actions. For example, if the patient's on ventilators, the peer might actually increase the air pressure of the ventilator to save the life of a human being. So this is an add-on case of the assistant, where the assistant would predict the onset of cardiac arrest. The peer machine learning capability might actually make decisions to save the life of a human. So that's another classification of your machine learning capability. Chatbots, I don't think I have to explain that. I think we're all familiar with that. You've probably seen or experienced in your life. If you go to Amazon, at the beginning of your chatting session with the customer service rep, you'll have to convince the chatbot that what you need is something that the chatbot cannot provide. Then it'll forward the call or your chat session to a human being. The last one is adaptive questionnaires. This is very important in certain scenarios, certain situations where a person or a human being has gone through trauma in their life. It's hard to diagnose whether they're going to have suicidal thoughts in their mind. So there's government-regulated industry developed and hospitals approved a set of questions that should be asked to the patient, but they have to be asked in a private setting. A doctor may not be comfortable asking, a nurse may not be comfortable asking. In those cases, machine learning-based, decision tree-based algorithms are used to create a adaptive set of questions based on maybe hundreds of thousands of questions being asked, and as the patient answers those questions, the algorithm chooses what the next question that should be asked this particular patient. Depending upon it takes patients' information into account, their medical information, their demographic information, and even their social media information into account as it creates questions to be asking for that particular patient. So when it comes to the traditional predictive model development process, it's very slow. If you go to most places, hospitals, organizations, they kind of use this waterfall method. If you're familiar with software engineering, use kind of waterfall-y method, then they're not quite using agile or scaled agile framework or Kanban or anything like that. They basically use waterfall method. Because of that, it's very slow. Let me zoom into some of the aspects. Typically, in healthcare, when you're developing a model, you're probably working with a data scientist and a doctor. And here are the things that you need and the process that you go through. From a model development standpoint, you'll have some statistical tools. You'll choose an algorithm or a set of algorithms, especially if you're using chaining, model chaining, then you need multiple algorithms. You need training data and test data to make sure you get the accuracy and support that you need for a given algorithm. And once you get the expected model accuracy, then you put the requirements together and you go through the proper software development lifecycle: analysis, design, build, test, develop. The reason for that is that once you have test and training and test data figured out, once the model is good to go, you still have to source the data for it to be executed real time. So you still need to source that oxygen saturation level, that ventilator data from the patient bedside device. So you still need to figure out how you're going to get that in real time. It could be going from the bedside device through HL7 messages, the EDI that I was referring to the electronic health record system. So you'll be going through sourcing, analysis, design, build, test, deploy. This is typical SDLC right here. This is where software development is happening, and this is more the model development lifecycle. Once you go through SDLC, once you implement, fetch, source the data, and execute the model, you get a predicted value. You send that value back to the model developer. This is not a real-time aspect. This probably happens once a week. You're sending all of them back to the model developers to say, hey, this is how the model is behaving in production, so that they can retrain the model. When you're using PMML, the benefits are these. By the way, in this example, this is more this is like a rules-based expert system kind of implementation. You're still doing your SDLC. You're still writing code to implement the model, which is a bad idea, right? This is a modern way of implementing the models, which is basically as you go through your model development phase, right? Data mining tools, predictive algorithms, and model validation. And you create a model in the form of a PMML, and you pick your favorite model deployment platform. So TipCore, Microsoft Business Server. There's plenty of tools out there where you can implement a model. It could be Python, just Python runtime. And then in the real time, you plug in the data that's from a patient, and some retrospective data about the patient. Could be family history of diagnosed blood pressure or diabetes and such, and then it predicts values, outputs. So this is a modern approach to model development and how predictive model markup language actually helps implement models quickly into production. I'm going to skip this slide. You'll get the slide. You can take a look at it, but the second one is more important. Now, when it comes to healthcare machine learning models, one key thing that I want you to remember is that typically doctors are restless. Healthcare industry is a pretty busy world. So you need to make sure that you give enough time to the doctors to be able to look through at content. You need to present that in an accessible fashion. So if you allow the data scientists to do their own development of the predictive model markup language, like the model, basically the XML, and then we give them the ability to just export it to a portal, right? And then the portal, maybe that it just takes and productionizes the model. The whole experience becomes a lot simpler to the data scientist and to the doctor, physician. So this is just an example or a pattern that can be used to accelerate the implementation of a model in a real hospital scenario. Right. There's certain challenges with PMML, but these are probably too deep for this conversation, so I'm going to move over to the next one. What it is a representation of how different events can be taken advantage of in a hospital to implement machine learning models and benefit from the models. If you're familiar with event-driven architecture, then this slide would be of most interest to you. If you're not familiar with event-driven architecture, I would suggest that you familiarize yourself. As a matter of fact, this is something I do want to write down for myself. Let's take a quick 10-second pause. All right. So I'll send a resource to you so that you can read about what is event-driven architecture. And I would recommend that you read this particular slide after you read the event-driven architecture contents in there. But for the sake of the completeness of the session, I'll go over this briefly. Assume that the patient is in a hospital and the patient is generating a lot of events. The patient's blood work is coming, patient's all kinds of vitals being collected, patient temperature, oxygen saturation, and hemoglobin levels, yada yada yada. And then there's clinical relevant events happening. What did the doctor do? What kind of decision? What kind of medications? What exactly did the doctors do? So those are all the things that are happening at a hospital with a particular patient. What it means, the next step that you see here is from left to right, how these events are leveraged to get to a point where a machine learning model or a machine learning algorithm can actually predict a certain condition in a patient and send alerts, or maybe even send a rapid response team, maybe even take action like increase the pressure in a ventilator to save the life of the patient. So from left to right, once a particular event happens, the event needs to be enriched. We might need more data for the model to be executed, right? That's the event enrichment right here. Then the execution of the actual model. And score assertion, we need to understand what that score means, right? The score might say 24. What does that mean? Is 24 too high, too low? Is it medium? Is it dangerous? What is it? That's the score assertion. And you have to record the score back into the electronic medical record of the patient to say at 10:30 a.m. in the morning, a particular patient had a 24 for cardiac arrest algorithm. So you have to record that back into the system. The next step is if 24 is deemed to be, once it is asserted, you need to have something that identifies how critical is the event. So you need to have a set of rules. Maybe this could be another machine learning opportunity as well to identify how critical is this clinically relevant event. Based on the output of this particular clinically critical event, you could have alerts go out or send a rapid response team, or maybe even take autonomous decisions and increase the oxygen saturation level or increase the ventilator pressure to give more oxygen into the blood supply. That's a clinical pathway that's proven to work for patients. These are examples of rules-based actions that can be taken, and these are examples of algorithms that I've implemented in the past. There's some that I'm working on right now that I cannot disclose, but these are historic things that I've done. And this will give you some examples for you to ponder over. And you can search for these on www or Google, and you'll get information. But these are examples of certain things you could take, and maybe some of these have evolved to the point where these are bulletproof. Some of these you can actually maybe productize them, and maybe you can make your own projects out of these when you get to that point in your travel towards getting your degree. Machine learning models and patterns. This is probably a little stretch goal for my topic for today, but I do want you to read through this, and when we cover the enterprise architecture topic, I'll try to bring this slide back into that session. And we'll go through this particular slide as a case study of healthcare and patterns in general in the enterprise architecture session. For now, we'll skip over this. All right. As you think about, okay, I'm going to do some model development, this is what you should do. Try to identify a problem that's worth solving, and then understand what accuracy levels and support levels do you need for a particular model. Pick your machine learning platform. Pick your machine learning platform doesn't mean get married to it, meaning don't fight with your friends and colleagues to say my R-based platform is the best platform out there, is my there's no point in doing that, because these things change. And then next, familiarize yourself with all the different algorithms that are out there. I introduced some of them to you. I tried my best not to propose a particular set of algorithms to you, because that's a bad thing to do, and you should choose yours at a given point in time, depending upon you choose Python or R or SAS. It's up to you. Choose your compute platform. If you're using convolutional neural networks or image recognition, then you would need some sort of a GPU or some pretty good, if you're still using CPUs, then you would need at least 64 to 128 cores, or maybe a GPU. The best thing to do is register yourself on AWS or Azure. They give 1 year's worth of free memberships. So go out there and start exploring their analytics tools. I would recommend Azure over AWS. Because for personal reasons, I'm a Microsoft guy. I do development in Java even today, and I use AWS platform, but I'm more leaning towards Azure because the tools are much more mature than AWS, which was not the case 4 or 5 years ago. But today, I would say Azure is breaking grounds, or maybe even Google Cloud if you like Google Cloud. Understand the data, the nature of the data is structured, unstructured, or semi-structured. Make sure that you get a good grasp of what kind of data that you're dealing with. And happy developing models. Enjoy your time as you develop models. And there is one resource that I will send you in the WhatsApp group, or maybe a Word document so that everything's in one place. There is a competition that happen out there, and these challenges are put together and published by the big companies, Apples and Googles, where people jump in and try to solve a particular problem using machine learning models. I really encourage you, go take a look over there. I'll send you the link in the Word document when I share. I want to see. This is my dream. Okay, I'm going to take a pause. I use the word dream. This is not my dream for myself. This is a dream of, this is my dream for you. I wish, I want to see one of you compete in the Kaggle competitions. It's a Kaggle. Don't write it down. I'll send you the link. But I want to see one of you participate in those competitions and solve the world problems. You might see some COVID data as well there. So, you know, staying at home, attending college is fun. But at the same time, every single one of you is a source for next best thing, next best innovation that could happen in this world. So I want to make sure that you're making yourself clear-headed, focused, and valuable. So let me go back to the participants here. So I'd like to conclude with a bunch of questions if you have anything. Let me see if I can please raise your hand if you have any questions. So Mr. Hari, you're a host now, and if anybody has any questions, feel free to ask. They could be about cars, rackets, anything that you can feel. I have about 2 minutes before I have to hang up and go to another meeting.
Well, thank you, sir. Students, if anyone having queries, you can ask Jai Kishore sir at once. Sir, hopefully, I think none of the students having any queries so far.
Okay.
Sir. So we will be meeting next
Yep.
week on Wednesday at same time, 6 p.m. sir.
Yep. And Hari, one thing I would like to mention to everybody is that based on these two sessions, if they have any questions that they might cook up between now and the next session, I'll try to make sure that there is some room in our next topic or next week when we meet.
Sure, sir. Sir, is it possible for you to share the PPT in the group, sir? Whatever the presentation you have.
Yes, I will share that. I need to declassify certain piece of information, and I'll send probably not the PPT, but I'll send the PDF versions for consumption.
Sure, sir. That if the students having any sort of things, they can recheck the slides at once, then they will be prepared for the coming week's session, sir.
Yep, correct. All right, if there are no other questions, thank you everyone for giving me this opportunity to share my thoughts with you.
So behalf of all Sir Udanikethan students, the pleasure is ours, sir, having you with us. Thank you, sir.
Thank you.